All right, as we look at the book in Chapter 3, in Section 3.5, we want to look a little deeper at learning about classes and objects, and I'm hoping that I can help clear up any of your confusion that you may have when you read this. Yet I'm not going to go over every single detail they provided, but some of the important stuff is when you think in an object-oriented manner, everything is an object and every object is a member of a class. Remember, class is the basic foundation of our Java programs, and creating every class belongs to objects, which is the topmost level in Java. Everything's an object, and every object is a member of a more general class. And it gives an example about how to look at desks and fish, and I'm sure you've looked over that. The statements represent an is-a relationship. So how does one object relate to another? The object in this case is a concrete example of a class, meaning it definitely exists as an item in a class. Expressing an is-a relationship is correct only when you refer to the object and the class in the proper order. And so you can say, in this example, my oak desk with a scratch on top is a desk. There's your is a relationship. But you don't define a desk by saying a desk is an oak desk with a scratch on top, because you didn't establish the is a relationship at the end. So there's some specific verbiage you need to use when using that terminology. An object is an instantiation of a class, or an example of a class. An instantiation happens when we use the new element and we actually go ahead and create an object. That's a true instantiation. Programmers also use the phrase is a when talking about inheritance relationships, and we're going to look at that in Chapter 4. We'll start talking about inheritance concepts. The concept of class is useful because of its reusability. Now, objects are designed so that you can reuse them in the proper ways. They gain their attributes from their classes, and the class may have multiple attributes, and the object gets the attributes from the class. All the objects have predictable attributes because they're members of the classes. So we know that when we design a class, its attributes are handed down to its objects. That kind of gets into what the inheritance concept is all about that we'll be going into. In addition to their attributes, objects have methods associated with them. Every object that is an instance of a class is assumed to possess the same methods. So let's move to something you're familiar with, a circle class. Every circle has a radius, and if we write a series of methods to go along with circles, we may establish that they all have diameters and various other factors that you would define for circles. And then you could think in parallel to if we define squares with lengths and widths and heights and areas and certain angles and things like that. So you could just have to kind of extend your thinking to how they are applying what are the attributes for an object. When you use an object and its methods, think of being able to send a message to the object to direct it to accomplish a task. So if you're passing something off to the method, it knows what to do with it, and it takes care of whatever calculation or task you need it to do. Even something as simple as set statements, set date, set time, are real common in the concept of a set to set parameters and a get to take those parameters back out. I talked to you the other day about setters and getters a little bit, and how we're going to dive deeper into those. Within the object-oriented programs, you're making requests to object methods and including arguments as part of those requests. Remember, arguments turn into parameters. Arguments are sent. Parameters are received by the methods. Some methods in an application must return a message or value. Okay, those are the ones that don't have void, have a data type, and have a return statement as the very last statement of the method. And remember, it can only return one data element. Within object-oriented programs, methods are called upon to return a piece of information to the source of the request. So the method that makes the call to another method that is a return-based method will receive a piece of data back. It can't go to a different method. It has to come back to the method that made the call to the method that does a return. Within object-oriented programming, sometimes you create classes so that you can instantiate objects from them, and other times you create classes to run applications. So they're talking about we create a main method in all of our programs, that's our application, and other methods that we write have a function that does a calculation or something like that. Application classes frequently also instantiate objects that use objects of other classes with their data and their methods. Well, you might even write classes that do both. Now, the same programmer does not need to write every class that he or she uses. Often you'll write programs that use classes created by others. And this whole paragraph right here really is like taking you to a development environment where object-oriented programming is live and well and being used by, might be 2, 3, 5, 400 programmers, and you're calling into a central repository of programs that will return your output. So how does this apply to you? Where have you seen this? Well, you've seen this like with the system class. You didn't have to create it, and you use the print line method all the time. Probably the other one is the scanner class. So you've seen this in action. You just kind of got to apply this thinking now to additional classes and methods. It then goes on to state that a class is an application because it contains public static void main method. Okay, so we always write those. The main method is the starting point for the application, but you will also write many classes that do not contain a main method. These classes can be used by other classes that are applications. So we might go on and write the actual circle class, but we may call it from a main method in another program because the circle class itself does not contain a public static void main method. It only contains classes associated with the circle. Methods associated with the circle, and attributes, setters, getters, and what are called constructors. And we'll be diving into that shortly. A Java application can contain only one method with the header public static void main street arg. So you cannot use that in the classes that are not applications that you call. Those are in the applications you